Hey, how's it going, eh? Thanks for dropping by. Holy, those are really spicy noodles. I was going to entitle this episode Junk Masters, but then I realized that there's actually a show called Lego Masters, so I thought, yeah, that's kind of close. We'll do something else. So I thought, how about I Can See Your Junk, which also turns out to be a show, but it's called what is it called? I Can See Your Voice. So that was no good either. Finally, I figured, why not just call it So You Think Your Junk Could Dance? And that's when I gave up. The point is, we're gonna make something out of junk today. There's a guy that lives a few houses down from me that's a retired aerospace engineer. And he's a short little rotund Russian guy, thick accent, and sharp as a tack. He must be over 80 now, and you can't get anything by this guy. Too smart. So anyway, now that he's retired, he is looking to maybe get rid of a few things. His house is just tiny, and it's filled with books and papers and, you know, Russian scientist kind of stuff. Oh, very, very spicy. One day he's telling me that he's got this old clock radio that doesn't work anymore, but he can't really bring himself to throw it away. And he wonders if I might take it off his hands. He knows I'd like to tinker a bit. So I say sure. We go over to his house, we get the clock radio, I bring it home, I plug it in, and all it does is make the alarm noise. It doesn't do anything else. It doesn't matter what buttons you press or switches you turn, it just makes the alarm noise. Because I'm 8 years old, I immediately take it apart, and it becomes pretty obvious, yeah, I'm not gonna be able to fix this thing. But like my neighbor, I am not willing to just throw this thing away. Look, nice switches. Ooh, speaker. And now seems like a good time to slip into the past and let a slightly younger me tell the rest of the story. Cue memory music. And then a few days later, we're talking again, and he's telling me how much he enjoys poetry. Like, not just a little bit, like he really, really likes poetry. Now, I'm not the poetic sort, but I do enjoy a good limerick now and then. And that got me thinking, maybe we could repurpose this old clock radio into something shiny new. And the little dim light bulb above my head came on, and I thought, poetry box. So a poetry box will work something like this. We'll have a collection of MP3 poems stored on an SD card, and when he presses the big orange retro button here, it will select one of those poems at random and play it. Now, as fabulous as that idea is, it does not satisfy my need to use every button and switch that's on this control panel. So we're gonna have to figure out some other functions for these, which means we're gonna go into planning mode for a second. Only for a second, mind. All right, here's a quick overview of how I think this should work. We've got a bunch of 3-position switches that we're going to use and some push buttons, and we'll fill this little window with a 16:2 LCD display. So we got a 3-position switch up here with either clock, music, or poetry, and from there you can subdivide that into English, Russian, or any language. And the reason I've done this is because he speaks fluent Russian, and I suspect he may know a few more. So we're going to throw some other languages in there. So this will set the scheme of what you're going to get when you press the random button. So if you press the random button, you've got it on Russian, and poetry, you'll get Russian poetry. If you select Russian music, you'll get, well, I guess Russian music. Although I hadn't really considered that as a possibility, but we're gonna add that in anyway. Okay, and then this is the controls for the playback, pause, resume, restart. You know what all those are. And over here we have a continuous function. So if you wanted to just continually play random pieces of poetry or random pieces of music and poetry, you would set this slider. And then of course there's an off position. Last one is an hourly charm. So, charm? Sure. Chime, how about? Let's do an hourly chime, and either on or off. That means on the hour it will go back to what's over here, and it will play either, you know, one of these things based on that on the hour, every hour. Probably not at night though. we'll have some sort of time limitation on that. So that's how it's all going to work. Let's get to work making it. I really wanted to salvage these big juicy slide switches, but when I went at it with a heat gun or even with solder wick, it got the thing too hot and it must have melted something on the inside of the switch and totally seized it up.
Oh,
so they're all
for
hooped,
feck's
which
sake,
means we're
eh?
going to have to order a few more to keep this project on the rails. We got 5 push buttons here. You'd assume maybe 2 wires apiece, or a single wire, and 5 other ones for signal. But if you look on the back here, this little ribbon cable has actually 9. So I don't know what is going on here. I've been trying to figure out what buttons, if you press a button, like what wires are connected to it. And I've gone through every combination and I can't find anything that makes this beep. So I don't know what's going on. I'm gonna pull this off, I think, and have a look at what's underneath. So this is the underside of that thing, and we've got some slightly degraded foam here. Is that what's providing the little push, or is there a little, no, there is an actual button behind there, you know, like one of those little domed things.
After a bit of humming and hawing, I decided I'd just take the foam off and see what's underneath. And this is what I was left with, a bunch of domed metal bits and a PCB.
I just wonder if there's some coating or something that's... What if I just cleaned it off? And bingo. Buttons are back on, secured with Kapton tape. Now we just need a piece of foam, which is exactly why I have a box called Foam and Velcro. And that looks like the exact piece I need right there. They all said I was crazy for keeping it, but look who's laughing now. All right, looks like we're good. With the button situation sorted and new slide switches on their way, it is time to think about how to make Poetry Box talk some poetry. And for that, I have resurrected my first generation Raspberry Pi. I like this because it's got plenty of GPIOs for interfacing with all those buttons and switches, and it's got audio out. Now, despite the presence of this little Wi-Fi dongle here, it will not be connected to the internet. This is merely for programming it remotely, so I don't have to hook this thing up to a monitor. We'll put all the music and poetry on the SD card and then write a little Python program that monitors the status of all the buttons and switches and then plays the appropriate selection when the appropriate button is pushed. Now, as tempting as it is to hook up speakers to this audio out jack, as someone around here did, you're going to find that this is actually not amplified, it's for headphones. So you're going to need an amplifier to make the sound loud enough to come through a speaker. And that's where this PAM 8403 amplifier module comes in. It's got an integrated potentiometer for volume and a little clicks on off as well, which is going to be pretty handy. So let's mock this up and see what it sounds like. Hopefully my wiring is correct here. I've got the amp hooked up to the original clock radio speaker, and the Raspberry Pi is playing something that the YouTube copyright goons won't shit the bed when they hear. So let's just turn it on here and see what happens.
So guess what? Winston Churchill's public speeches are not in the public domain. So we're just gonna talk right the fuck over it until he's done.
Yeah, that's pretty good. It goes pretty loud.
Stupid feckin' trolls everywhere.
A little bit of distortion in the background, but I think I'm okay with that. If you type in pinout into a Raspberry Pi terminal, you will get something that looks like this, which corresponds to the pin header on your Raspberry Pi. All the little pokey bits there. And it'll tell you where your power is, where your ground is, and where your GPIOs are, and what their numbers are so that you can program them. We can use any of these except for GPIO2 and GPIO3. That is the I2C bus, and we're going to be using those 2 pins in order to talk to the little LCD display that's on the front of the clock. So we're going to leave those 2 alone, but any of these other GPIOs we can use for our buttons and switches. Now, before you go all crazy hooking shit up, it's a good idea to make sure that things are going to work the way you think they're going to work. I've got a simple push button switch here. The white wire goes to GPIO 7 and the red wire is going to ground. When I press the button, Winston Churchill should launch into his spiel.
When Napoleon laid Boulogne for a year with his flat-bottomed boats,
Now, is he saying fat bottom boats or flat bottom boats? Sounds like fat bottom boats, and we all know that they make the rockin' world go round. This is my cheat sheet for the ribbon cable on the button pad, you know, this thing. And if you look, you can see that 1, 3, and 4, and 8 can all be ground. And then the signal pins can be 2, 6, 5, 7, and 9. So really we need a total of 6 pins to make this work. 1 ground, 5 signals. So if we go back to our GPIO placement, I think I can use 1, 2, 3, 4, 5 plus a ground. So a 3x3 header would be nice there. Oh, and I just happen to have one right here in my hand. Let's hook it up. Les boutons sont finis et mon pencil est grand. Now for les switches. Here is one of the original slide switches, and this is the replacement. How's that for 40 years of progress? I have never used one of these 3-position slide switches in a project before, so I had to use the old beep beep function on the multimeter to figure out who is connected to who here. And this pin turns out to be the common pin, and then you get signal from either of the rest of the 3 depending on the position of the switch. So you'd think 3 signal pins, 1 ground should be enough to make this thing work. But then I thought, wait a second, a 2-position switch, an on-off switch, has only 1 signal wire coming from it and a ground. So shouldn't this have only 2? It's an n-1 kind of situation where n is the number of positions of the switch. I think that's right. So we'll get signal out of this one and this one, for example, and then no signal at all to indicate the 3rd position. I think my logic is sound. I'm sticking with it, and that's where we're going to plan on here. So if we go back to our GPIO chart here, we know that this is taken, and all of these are already gone. And I have a 6x6 pin header here that I would like to use, and I think I'm just going to chunk that right along here. And then I'll be able to use all of those pins. So for our 3-position slide switches, we need 6, and then an extra one. So we need a total of 7 GPIOs. 1, 2, 3, 4, 5, 6, 7. We got an extra couple in that block that we can use for something else later. Now there's a beauty connector for you, eh? And at the end of the rainbow, a bouquet of switches. Now I don't know what the big deal was with sliced bread, but these heat shrink connectors, bees fucking knees. Not only do they provide insulation between the terminals, but they provide a huge amount of strain relief so that you're not needlessly stressing out those wires and ripping them off. Highly recommended by Dork on Internet. So let's plug this in and give the pie some juice. Now to make sure that all my buttons and switches are drinking the same Kool-Aid, I've written a little program that will output some stuff to the LCD here when buttons and switches are activated. All right, looks like we're ready to go here. Each one of these buttons has been reprogrammed for, you know, something else. So when I press them, hopefully what happens is it shows what it'll do. Yep, first one is pause. I think the next one is resume. There we go. This button here is restart, and this one is stop. Okay, so that's so far so good. Last one is random, so that'll be the one you press to get whatever random selection you're into. Oh, and the switches, so that's the second line here. I've only got switch 1 programmed, but if we give this a little slide and then refresh it, oh, it goes to music, and then finally if we go to the 3rd position and refresh it again, we're on clock. Oh, holy fuck, I just realized Raspberry Pi does not have a real-time clock. So, yeah, that's not good. We're gonna need a real-time clock module. So here's one of those real-time clock modules. It runs off the same I2C bus as the LCD, which, you know, maybe sounds like a bad thing, but you can actually just daisy chain these together, and they each have their own address, so you can talk to them individually along that bus. What I'm saying is you don't need another 2 pins to connect to this thing separately from that. We'll just cook them together. So let's do that quickly and make sure we get the clock running. So I attached the real-time clock into the I2C bus. You can see it's chained from the Raspberry Pi through the clock and then to the LCD display. And we've got the correct time on here. I just set the time on here, and that should be good until, well, I guess until it's not good anymore. I don't know when that'll be. Now I think we just need to put this thing together. right away we got a couple problems setting this thing up. First of all, we're going to have to find some way of interfacing these little switches with the control panel. And secondly, the original handles for those switches, as lovely as they are designed to fit on this little spade bit. And that is not what we have here. So we're going to have to do something about that as well. Sometimes the best way of dealing with these kind of problems is to just toss them in the blender and see what comes out. I'm here all week, folks. So I whipped up a few clips here that will fit over top like that. We'll glue those in, and then the switches just kind of fit inside there. And for the handles, this is the original handle, and this is the replacement. Obviously not quite as purdy, but nevertheless should do the trick. It's got the appropriate hole for the switch. So it fits nicely in there, and with a little bit of friction, but that's good. So there we go. Okay, let's try one of these out. Oh, please work, please work, please work. Okay, held in place. Off, auto. Damn, that works pretty good. Go figure. And I got a little bracket here to hold in the LCD panel. It'll just fit over top like that. Not too bad, just screws in on the four corners. Which is why you want to keep every fastener you can possibly find. And this is just the small ones. Looks like I should be able to mount this Pi on the roof here, and the back will have a little opening for the USB, so I can stick the dongle in at some point if I need to update something on the Raspberry Pi. And check this out. Remember that amplifier deal? Well, that is going to sit in this little cage here, and this is the original volume knob. And we're just going to mount it right in here. It's hard to make this happen, but you get the idea. We're going to mount it in here, and it fits actually just perfect so that it protrudes out the side. So yeah. Now I'm thinking I'm just going to reuse the old power cord here and use this AC to 5 volts DC converter. But it only, I think, supplies 1 amp of power, so I kind of want to hook everything up. Oh my God, it's a terrifying mess of wires now. And, and see how many amps it's going to actually pull. So I've got it running at about a 0.5 amp right now, and I will fire up the sound making machine and we'll see what else happens.
When Napoleon laid Boulogne for a year with his flat bottom boat.
Yeah, it's not significant. So a 1 amp power supply should be plenty for this. If you keep your teeth nice and sharp, you can gnaw holes in plastic like this, and that is for the USB port on this Raspberry Pi. It'll just fit something like that. And I have a little plastic plate here on the back that I'm just going to glue down, and that's where the Pi will mount. Little screws. So yeah, let's get this set up. I'm about to put this thing together, and I gotta say, there is something fucking weird going on here, because so far there have been no major problems with this thing, which is definitely not normal. So let's just tuck this all into a nice tidy package and see if she'll work.
Oh, how am I going to fit all this? Oh, you fit you. Where are they? Screws in a bag. Stupid baby screwdriver. Son of a son. They're just dirty. They're no good. This might actually work.
And done. Seems all right. Oh, that's a little crusty. Oh, it just needs to come up a little bit. That's not a problem. It's a newel post, so we can just lift that up. There we go. Beauty. Okay, moment of truth here. We shall plug it in, let it boot up, and see if the default program will run. There we go. And is the time correct? It is. So, hey, that's not too bad. Buttons functioning properly. And I don't think there's no action on the switches right now. So let's move on to the programming phase. What's that old expression? Code drunk, debug sober. What do you say we code this thing up in real time? That way you can get a kind of a feel for how the sausage is made. And if you just looked at your timeline to see how much was left in this stupid video, you'll realize I'm just shitting ya. Nobody wants to see me code, least of all me. So I'll be back when this is done. Anybody familiar with this channel will know that I like to put my heavy metal balls anywhere that I can. So I printed up a couple of these little cups here and glued them down to the bottom of the case. And I'll hot snot these balls in there. And what that's gonna do is obviously give the thing a little bit of gravity, because it's a little bit light, and things that are light feel cheap, and I didn't really want that. So add a little mass on the inside and it starts to feel heavy in the hand, which is nice, if you know what I mean. Poetry Box is now jazzed up on about 400 lines of premium organic gluten-free Python code and a gig or so of poetry and music files. But we've still got a problem with this, because this is not your standard bedside table clock radio. This is actually a under-counter mount one, which is what these little knobbies are for. And the problem with that is the speaker is on the bottom and it's lying flat against the table, which means that the sound from it sucks. So, I mean, that sounds okay, but you really need to tip it up like this in order to let the sound out. So we gotta do something about that. Something like this, maybe? Now that's much better. I do believe it's demo time, boys and girls. Starting with this switch all the way over to the left, it's everybody's favorite clock mode. Gives you the time and the date, as well as a little asterisk up in the corner will indicate whether or not the hourly charm mode is on. No, it's the hourly chime mode. I don't know why I fucking keep doing that. It's the hourly chime mode, and that is controlled by this AM FM slider here. The right is on, that is off. So that will operate between the hours of 9 a.m. and 9 p.m. So if you got that on, it's going to spit something out on the hour. Now, if we move this over one, we get piano music. And the reason why it's piano music is because it's being selected by this bottom slider here. So over to the left is orchestral, then it's anything, and then it's piano. And we can do the same thing with poetry. So over to the right is Russian, this will be any kind of poetry, and this will be English poetry. You get the idea. So I changed that up a little bit. This slider does different things this slider does different things depending on the position of this slider. So with Russian poetry selected, if we press the big orange button, we should get a random selection of Russian poetry.
Hi, today we're going to read a Russian poem.
And there you go. Now, this button is pause. It'll tell you it's pause. This is resume. This one will restart it.
Hi, today we're going to read a Russian
and this
poem.
one will stop it. And we can do the same with, for example, let's just pick random piece of music, so it'll select from any of the music directories. There you go. And you see that the title scrolls along the bottom. Who wrote the piece, as well as how long it happens to be. And that can be important if you've selected something that may be 45 minutes long. So you might want to know that. The last button is the continuous function button. So right now we've got it on mixed music. And if we slide this over to the right, it's going to start playing a randomly selected pieces of mixed music. Maybe I should just change it to something a little more, let's see here. Let's go piano music. So it'll only play piano music and it'll play it continuously. So let's slide her over. Picks a piece at random. We press stop. It's just, because it's set to on, it's gonna pick another one. So, as it does. All right, so if we slide it to off, press stop. We're clearly not on off. There we go. There we go. If we slide this all the way over to the left, what we get is a random selection of pretty much anything that is available to play. So in this case, we get poetry. If we press stop, it'll select something else. And now we're getting piano music. Now we're getting some Dizzy Gillespie. So yeah, you don't know what you're gonna get. Obviously I have to stop that because again, the YouTube copyright goons are gonna beat my ass if I play any more of that. In fact, that may already be too much. I don't even know. So there you have it. That is Poetry Box for you, from bizarre concept to bizarre finish. I think it's great, but you know, your mileage may vary. Now remember, this case here is probably 35 or 40 years old, and most likely would have ended up in the landfill somewhere in between there. But it just goes to show you, you can kind of repurpose this stuff. We probably should have been doing this the whole goddamn time. Anyway, what can you do? Maybe start now. So next time you're thinking of throwing something like this away, maybe consider making something new out of it. Just a thought. Thanks for watching. Cheers. And now to send us off, how about a little poetry?
Hi, today we're going to read a poem.
Oh, I should mention, the guy that's about to read this poem has his own YouTube channel. His name is Sasha Volokh, and I think he does a great job reading these poems. So if you're interested in that kind of thing, I'll put a link to his channel below. And take it away, Sasha.
Edward Lear was an English poet and pioneer of the genre of nonsense poetry who lived between 1812 and 1888. This poem, The Pobble Who Has No Toes, was first published in 1877. The pobble who has no toes had once as many as we. When they said someday...